Before I do anything else, though, I'd love to give you that head start in the form of a graph. What you're seeing here is a simulation on GeoGebra with the base function y equals x squared. There are plenty of other base functions out there, but I'm using x squared, which is the quadratic, because our next unit will be on quadratics, and this is going to be directly related to that. You're going to see a bunch of other functions laying around here on the side, but don't worry too much about them yet. I'm going to talk about each individual kind of change as we see it by toggling on and off each kind of function. Let's start off with the first kind of change that we talked about, shifting. We talked about how that shift could happen either up, down, left, or right. I'm going to start off with a vertical shift. Watch what happens when I toggle on G compared to the original function. Notice how this is basically the exact same thing. I could zoom out, show you the whole thing, and you can see it's basically the same thing, except it is shifted up by 2. But let's look at that function real quick. It's just the same x squared, but I added 2. And look at how much we moved up. From its original place at the origin 0, it moves up vertically by 2. So, when you're adding, after you're done doing the big function-y change, which in this case is squaring your input, you then shift up by 2, as you can see here. What do you think is going to happen if, instead of adding 2, I change that for subtracting by 4? If you guessed that the entire graph will move down by 4 from its original place at 0, you'd be correct. Awesome work. So here, when you're adding or subtracting to the outside, it affects which direction we shift up and down. Notice I said from the outside, because this isn't directly being applied to x. This is being applied to x after we square it. What happens if we apply things to x before we square it? Let's find out with the next two. With x minus 4, all squared, and x plus 5, also all squared. Now previously, if we saw that adding from the outside makes a vertical shift, adding from the inside, you might infer, will probably result in a horizontal one, though maybe not the one you think. Intuitively, you might see x minus 4 and think that it's going to go in the negative direction, which will be left. When in reality, when things are inside the function, like inside Dotson in this case, it's going to shift over to the opposite direction. So x minus 4 is considered positively moving to the right. Meanwhile, x plus 5 will be the horizontal shift, but negatively. We'll see why this is in a second, but you can probably see now, if you add directly to the x and put it in parentheses as such, it results in a horizontal movement. A lot of identifying these kinds of transformations is a very visual exercise, and doesn't really need much in the way of math, other than just some number sense to identify when numbers are positive, negative, or bigger than certain thresholds. Let's move to the next one. For r, the only difference between this one and the previous one is a negative sign. This isn't going to shift anything, but instead it's going to move on to a different kind of transformation we've seen, a flip. Usually when you see a negative sign multiplied to something, we think of its opposite. And we mentioned before how we're talking about vertical flips. So with that in mind, you can probably guess that adding a negative sign to the outside, its transformation, flips it over the x-axis, and creates a mirror on the bottom, or on the top if it were originally on the bottom. So, if we ever have a minus sign multiplied, or any kind of negative number multiplied outside of the function itself, so outside of Dotson, it creates the flip. In a similar fashion, we also look at that outside number being multiplied to talk about our final transformation, stretching and squishing. Have a look here. With s and t, I have 2x squared and 1/5 x squared. The big difference here is that one of these numbers is a number bigger than 1, and another one is one between 0 and 1. So here's what happens when I trigger the 2x. It's a little bit skinnier, but you can imagine that the arms on this function are being pulled up and up and up to the point where they're starting to close in, and it's starting to stretch itself out. Again, that goes to it's being pulled from the top and from the bottom, and this is what that might look like. Conversely, if the arms were going a little bit more inward when they're being pulled and stretched, if you squish them, they will then go a little bit more outward. They start to stretch out. So that's really the squish. You can imagine squishing like the two arms of the quadratic are trying to lift a boulder, and they're struggling. Meanwhile, a stretch is when it's nice and big and macho and it's actually able to lift the rock. It's a good way to understand it. All of these are ways that we can go from the base function, which I've kept on the screen this entire time, to other transformations. But they're not exclusive from one another. You can combine them. You can have shifts, stretches, squishes, and or flips all at once. So watch what happens in this case. 3x squared plus 6. The 3 on the outside of the function indicates that we're going to have a stretch since it's bigger than 1. And the 6 on the outside means that the whole thing is going to shift in the vertical direction upward, which is what we see right here. It looks a little skinnier from the stretching, and the 6 is it being bumped up by 6 spaces. The next one for G1, negative 2/3, x minus 3, all squared. The negative indicates that it's going to flip. The 2/3 means it's going to squish, going to get crushed by a boulder. And the x minus 3 indicates we're going to have a horizontal shift, as you can see here. And finally, 1/7 times x plus 2 squared minus 4 shows an example where all 3 kinds of transformations all come together. We're being squished by the 1/7 because it's between 0 and 1. We have x plus 2 inside the function, so it's going to shift horizontally. And minus 4 on the outside, which means it's going to shift down. So we have a lot to talk about to see how all these values come into play. But I did want to do this demonstration first. We'll be back in the other document after this brief break.